Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be kicking off our very first series on solving a problem using machine learning. Now we're going to be using probably the most common data set out there for beginners, and that is the iris data set. For those who don't know what that is, the iris data set is a whole bunch of dimensions of the iris flower, the sepal and petal lengths and widths. So there are four dimensions, like I just said, the sepal length and the sepal width, along with the petal length and petal width. And what the dataset does is it maps 150 classes to those dimensions. And those classes are going to be different species of iris flower. And in this case, there are three different species that we're trying to be predicting using the dimensions. So this video is going to just break down what that data set looks like, start visualizing some of the data, and get us ready to start using machine learning in order to solve this problem. So without further ado, let's jump over the Jupyter notebook and I will start breaking down the data. All right, swapping over to our notebook, let's go ahead and start importing some modules. So I'm going to be using pandas, so import pandas as PD. I'm going to be using NumPy, import NumPy as NP. I'm going to be using pyplot, import matplotlib.pyplot as PLT, and I'm going to be using sklearn, so import sklearn. Now, if you haven't heard of any of these packages, I actually have done tutorials on all four of these that you can go through. It's beginner tutorials, how you can use these, what some features are, and highly suggest that you go check those out. I'll put the link in right now to pass you over to those. But for now, I will push on. I'm actually going to import one more module, and that is going to be called Seaborn. I haven't covered this one, but it's just another data visualization package in order to help you see what your data looks like and find some trends. And typically you'll see Seaborn input as SNS, so I'll go ahead and do that. Now those are all the packages, but I'm also going to be pulling some modules from sklearn. So from sklearn, I'm going to be importing datasets. Also from sklearn.preprocessing, I'm going to be pulling min, max, scalar. Don't worry about what these are right now. As I use them, I will go over what exactly they do. But for now, just go ahead and run that cell, get those packages loaded, and we can move on. So I will start right off the bat with pulling in our data. So we're going to make a new variable data, and we're going to use that datasets module we just imported. And we are going to use the function, so datasets.load_iris. And this is just going to load the iris dataset for us to start using and looking at. So if I go ahead and print data, I can show you what's in there. As you can see, a whole bunch of data points, what the target class is, different things like what the name of the species is that each of these targets is referring to, and just feature information, a whole bunch of different stuff. Now, if you want to see what each of the columns are, now this is a dictionary, so you can see the keys. And this will just give you the overall headers of what you can pull out of here. So you can see data refers to the actual data points, target refers to the prediction class that you want to be predicting in, a whole bunch of other stuff like feature names, target names that we'll be using. But for now, we will start importing this as a data frame. So I'm going to define a new data frame, df, and that is going to be equal to pd.dataFrame. And we are going to be passing it. Now, when you want to refer to anything in this data set, you need to just do dot whatever the key is. So this is going to be data.data. That's going to be pulling the data points. And we want to link those to the column names. So that would be columns equals, and in this case, it's going to be data.feature_names. And you can see that is right here where I got that. So let me just display this to show you exactly what we did. And you can see I pulled in the data, put the column headers with what the actual feature names are, and you can see all of our data points. So 150 data points were pulled in with all the different values. Now looking at this, it looks like values are maybe between 0 and 7. A good thing to do in machine learning is to scale your data. So you want to put it maybe between 0 and 1 or -1 and 1, or it depends on your problem. In this case, I'm going to put it between 0 and 1. And I'm going to be using that other function that we pulled in, which is min-max scalar, to do that. So I'm going to be finding a scalar, and that is going to be equal to min-max scalar. Again, this is the one we just imported from sklearn. And we're going to be using this to get our data in between 0 and 1. Now what min-max scalar does, it subtracts the minimum value and divides by the maximum value. So subtracted by the minimum value will put the smallest value at 0, and dividing by the max will put the highest value to 1. And anything in between will just be scaled from there. Okay. So in order to use this, we need to fit the scalar to our data. So it'll be scalar.fit, and we're just going to pass it in the data frame. So scalar.fit df. Next, we are going to be making scaled data by saying scaled is equal to scalar dot fit underscore transform. And we're going to be passing in the data frame to do that. And now we could say a scaled data frame is equal to pd.dataframe, and this is going to be scaled, and it's going to be columns is equal to the same columns that we had before. So what did we do here? Well, we scaled the data, and now we're making a new data frame called scaled data frame, where we're passing in the scaled values and the columns that we're just copying from the original data frame. So let's go ahead and display that so you can see. So displaying the scaled data frame, I'm going to get rid of this statement up here and this print statement. Clean up our output a little. And you can see now all of our data points are scaled between 0 and 1. And we should be good to go to continue on. Now, what is missing from here? Well, these are the input features, but we are missing the output features that we're going to be using. So we're going to have to make a new column for those. And I can do that by taking the scale data frame, making a new column called target. And we are going to be setting that equal to data.target. Now, if you remember when I printed the data set before, there was a key called target, and those were all values between 0 and 2, depending on what class they belonged in. So let me go ahead and just print that, see what I did. And you can see our target class is in here, has a whole bunch of 0s, 1s, and 2s, depending on what class each of these belong to. One more thing that I want to do. Target tells me an integer value, but I would really like to know which species each of these belong to. So I'm going to make first let me make a dictionary. And that dictionary is going to be just target dict. And this dictionary is going to be mapping those integer values to their actual string values of what the species is. So how do we do that? Well, it's going to be a dictionary. We are going to be zipping and those values. So like I said, the target values are 0, 1, and 2. And we're going to be mapping those to data.target underscore names. Now data, the target names within data, those are 3 values, and it is each of the 3 species. And I can go ahead and just print this target dictionary to show you what that looks like. So you can see 0 class is the Setosa class, 1 is the versicolor, and 2 is the Virginica. Now that's great, we got it in a dictionary, but we want to make it an actual column within our data frame. So we can do that by, again, making another column. So I'm going to call this one target underscore name. And now what we want to do is we want to map that dictionary to the target column. And so we can do that by saying I want the target column. So scaled data frame at the target column. And we are going to be mapping. And we're going to be passing in that dictionary. So target underscore dict. So this is taking all of those target values that I have right here and passing them through the dictionary to get the string values. So if I go ahead and print that again, you can see we now have another column that is mapping what exactly those target names are. Okay, now that we have our data in, we want to do some visualization of what the data looks like and just getting a sense of if we have any relationships between the data. So let's start first with figuring out how many data points of each that we have. I'm just going to do that using a pie plot. And so we can go ahead and do a plt.figure. Let's change the fig size to something like 7 by 7. And if I use plt.py, we can pass in the scaled df. And now what we want is we want the counts of each of these target values. So how many zeros are there, how many ones are there, how many twos are there. So in order to do that, I could say I want the target column, so dot target. And pandas has another function called value underscore counts. And this is just going to pass how many, it's going to pass the count for each unique value within this column. Now labels is going to be equal to the data.target names. Again, those are the species of iris flowers that we're going to be predicting. And since I increased the size of the figure, actually I just realized I spelled fig size wrong up here. So go ahead and correct that if you copied me. Since I increased the size of the figure, I need to probably increase the size of my text just to make it easier to see. So I'm going to use text properties. So text props is equal to, is looking for a dictionary, and I'm going to be passing in font size. We're going to set font size equal to 14 point font. Now, last thing I need to do is I want to just assign colors to each of these different species. So that's going to be equal to colors, and colors is going to be equal to a list. And here's where we pass in 3 different colors. So I'm going to do it as red, blue, and green. So this gives me 3 colors for each of the different species, just so we can see which ones belong to which. And I will do a plt.show. And we can see it pops out. Now, I want to know some values of how many belong to each class and what percent of the data set is each of these. To do that, we can add one more variable to this pie chart. And I'm just going to do a new line so you can see what I'm about to do. And this is going to be called auto percent, so auto PCT. Now, auto percent is automatically going to pass in a percent value. So the value times 100, it's already in percent form. We want to go ahead and display that, but I would also like to know how many values is that percent. So what is the actual number of data points in each of these different classes? So to do that, we're going to have to break apart that value. And so I will use lambda of x. So it's going to take this x value and it's going to start mapping it to a string that we're going to create right now. And so the first one is going to be the percent value. I'll call that p. And I want the percent value to be a 2-point floating point. Now, I also want to know the number of data points, the actual number. So I'm going to pass that in between parentheses. Now, again, looking for another value, we're going to call this one v for value. And I want that to be a 1-point floating point. So now that we have our string, we need to pass in those values. So that would be dot format. And p is going to be equal to x. Again, x is this percent value. It's already passed in by the pie chart. And so we can just go ahead straight up pass that in as p. Now we need to work backwards and use that x value to figure out what the actual values for each of the data points are. To do that, v will be equal to the percent value, so x, times the length of the scaled data frame. So how many data points we have. And then it's going to be divided by 100. Now, if you aren't tracking what I did here, don't worry too much about it. I will show you right now when I run it what it does. This is, again, passing in the percent value. So the Setosa class is 33% or 1/3 of the data set, and it has 50 data points associated with it. And Obviously, this data set is for beginners, so it is evenly split in thirds between all of the classes. So each of them have 50. Okay, moving on. Now that we know that we have a balanced data set, let's go ahead and look at some of the comparisons of features. So to do this, I'm going to just look at some of the mean values of the different measurements. So I can pass in scaled df and dot group by. Now group by is going to, whatever column I pass it, is going to group all of the similar features together, and then it's going to do something to all of the remaining columns. So I'm going to be grouping by the target column. So this is the output column. And for all of the number values, I want to take the mean of them. So I'm going to do dot mean. So again, this is, if I go back up here, combining all of these similar target classes and then taking the mean of each of these different columns that have numbers in it. So the target name does not have numbers and it'll ignore it. Let me go ahead and just print what it did. Sorry, let me display it actually. Displaying it, you can see here's our target class and here are the means for each of the different features. Now I can see it here, but I would like to visualize what this actually is doing. So I'm going to be defining some things. First, I want to know all the features, and these are the column titles up here. So features is going to be equal to the means dot columns. I am going to be defining all of the x-axis values, and that is going to be equal to np.array. I'm just going to make it 1, 2, 3, and 4 because there are 4 features. So I'm giving an x value to each one of these features. We're going to make the y values, and those are going to be equal to all of these mean values that I just created. So it's going to be means dot values. What dot values does is it gets rid of the index, gets rid of the columns, and only gives me the array with all of these in it. Okay, now that I've got that, I can go ahead and start working. I'm going to make this into a bar chart. So I'm going to first do a plt.figure, change the fig size to maybe 10 by 5 because it's going to be wider than it is taller. I'm going to do a plt.bar, and I am going to pass in x-axis obviously as the x-axis. Now, since I have 3 classes, I'm going to be doing these bar charts right next to each other. And so I don't want them to be overlapping on top of each other. So I want to space them out a little bit. To do that, I can actually just subtract some offset from the x-axis. So in this case, I'll do minus 0.25. Now the y-axis is going to be equal to y-axis, the ones up here. Now I want it for the very first class. So I'll say y-axis at 0. And that'll give me the first class. I'm going to set the width of the bar chart to be equal to 0.25. And I'm going to set the color equal to red because I want to match the classes to what I did up here in the pie chart. All right, so what did this do? Well, it took the values for the first class, the target 0 class, and it made a bar chart, but it offset it by 0.25 so we can make room for the other 2 classes. I'm going to do the same thing in order to print the remaining 2 classes. So the second bar chart, I want to just do it right on 0. So this is going to be right in the middle, so I can remove that offset. The y-axis is going to be looking for the index of 1, so the second set of values. The width is going to stay the same. The color I'm going to change to blue, again, to match what I did up top. Now, the last one, instead of subtracting the offset, I'm going to add the offset. I'm going to be looking for the second set of y values, and I'm going to change the color to green. And now I am plotting the features as my x value. So I want to change plt.xticks. Originally, they were mapped to the values of 1, 2, 3, and 4. I am going to take those values of 1, 2, 3, and 4. Remember, that's what I defined up here. And I'm just going to map them to what the actual features name was, which is my features value right up top here. Last thing I'm going to do, I am going to change the legend to be equal to the actual names of the Irish species. So to do that, it would be data.target underscore names. All right, let's go ahead and show exactly what I did here. Okay, I did not pass an S here, so this should be means.columns, and there we go. Okay, so as you can see, those offsets, for instance, the red class, I had an offset of negative 0.25, so it just shifted this over to the left of the middle in order to get all three of these on the same x-axis value. But you can see, looking at each of these different species, the red class is definitely different than the other two. Now, for the most part, like sepal length, the means, these are definitely different. If you look at other ones, like it's getting closer between the blue and the green class for something like sepal length, but for the most part, they're fairly well, the means are fairly well separated. So we should be able to make a fairly good classifier on these. Now, something else that is super useful, and this is why I imported the Seaborn library, because we can start graphing the features against themselves to figure out if we can find any trends. And I'll show you exactly what I mean. So I'm going to start with sns.pairplot. Now, again, pairplot is graphing the features by the features. So the x-axis, like this one here, will be the feature names, but the y-axis will also be the different features in order to see any trends between the two. I am going to be passing in scaled data, so the scaled data frame. However, if we remember back up to the top, I did add this. I have two target values here, right? So I have the target in the integer form, and I have the target names. I just want one of these, so I'm going to keep the target names and get rid of the target column. And when I'm passing in here, I can actually just go ahead and pass in what those column names were by saying scaled data frame dot columns. So these are all of the column names, but I only want the first column, the second column, the third column, and the fourth column. Those are my input features, and I want the fifth column. That is the actual name, the string name of the classes. Okay, so that's taken care of for the data that we're going to be plotting. Now, I want the hue, or the color of each of the data points, to be equal to that target name, so that output class. Again, if you remember up here, target names is this one right here. It's just name. And then the last thing I'm going to do is I'm going to change the color palette that we're using. So palette. And I've done some experimenting, so I know set one is going to map these to red, blue, and green like this one. But you can go ahead and check out some documentation of the different kinds of palettes that you can use, or the C maps you can use for PyPlot. Now, again, Seaborn uses PyPlot as in the background, so I can say plt.show, and this will go ahead and show my plot. And it may take a second because, especially depending on if you have more data. But what this is doing, if I can zoom out a little bit, is again taking the different features. So in this case, in the bottom left will be the sepal length by the petal width, and you can see it's mapping the different species as the different colors. And it's very obvious that the red, or the Setosa species, is very different than the other two. Now, the blue and the green, the versicolor and the virginica, they are different in some of these plots, but there's a lot of overlap, especially when you're looking up here, like the sepal length by the sepal width. There's a lot of overlap. So predicting in the future, I imagine there's going to be a lot of confusion between these two classes, and we, for the most part, will nail the red class just because it's so far separated between the other two. Now, one more cool thing you can do, I'm going to actually just copy exactly what we did up here. This is just another way of visualizing it. to make it look maybe a little more interesting, and you can see some of the trends a little bit better. So I'm going to pass in the variable kind. I am going to set that equal to KDE. So KDE is the kernel density function. And if I go ahead and run that, you can see instead of plotting the points like it is up here, it's going to be plotting the density distribution of each of um, the points. So you can see these like density rings of how close they are to the center point, if you will, the mean point. But you can see, again, helps us visualize the data a little better and figure out if we have trends in our data and if we're going to be able to use this. So I'm going to stop here. This is just introduction to the data. You can see some of the different trends. You can see how we can visualize some of it and how we can start to get this ready and put it into form for machine learning to take this and try to map some of the outputs to the inputs. Next video, I'm going to be using a decision tree to map these, and we'll run through exactly how that works, what we can get from it, and we will go ahead and, like I said, stop here. If you got anything out of this, if you enjoyed what I did here, definitely like the video. Stay tuned for further videos in the series and other demos I do with different data sets. So thanks, and I'll see you in the next video.